so sorry. I know. Someday I'm going to get a new one, and it's not going to do all that to me. Okay, so let's look at these. What is the slope of the graph? So we just need to count rise over run, correct? That's how we find slope on a graph, rise over run. I'm going, and if it includes the origin, always use the origin, okay? That's just the easiest place to start. So I'm going up to 40 and going over to, ooh, that's bad. Can't use 40, can I? Ooh, can't use 40. So where can I go to? I can go to 60, can't I? Yep, I got 60 up, and I can go over, and it comes down at 2. 60 over 2 simplifies to 30 over 1. And let's talk about what 30 over 1. 30 means what? 30 is representing what? Miles, not X, Y. And the 1 is representing what? An hour. Okay, so we've got 30 miles an hour, correct? All right, what does this slope represent on train number 2? Okay, so we just said 30 miles in 1 hour. The relationship between time and distance for train B is given by the equation above, where X represents the hours and Y represents the miles. Find the slope for M. What is the slope here? Right, because you've got a Y equals MX. Is that proportional or non-proportional for 8th grade math? Proportional, very good. Okay, so Y, we've got 45 to 1, which means we have 45 miles in 1 hour. Or you could have said 45 miles per hour, correct? All right, which train is moving faster, train A or train B? Train B is correct. Why do you know this?
Because the constant rate of change is higher.
Correct, because higher rate of change. Remember, your slope is your rate of change. Okay? The time distance for train C is shown in the table above. What is the ratio of distance to time? Okay, so let's see here. As I've told you before, y2 minus y1 over x2 minus x1. You can do that whole formula if you would like, because that's the correct way to do it. And I would suggest, I don't know why, but it is, I'm not feeling any air movement in this room. It's driving me nuts. Okay, that's why I don't wear long sleeves very often. Okay, so I can go up to this table and do y2 minus y1 over x2 minus x1. And I'm going to start in the middle. So I'm going to do 315 subtract 210 over 9 subtract 6. 315 subtract 210 is equal to what? 105. And 105 and 9 divided by 9 take away 6 is 3. So 105 divided by 3 is what? 35 over 1. All right. I also could have just done the change in y over the change in x. And what I'm saying by that is I could check these. If they are all the same, then I know that I've got a constant rate of change. If they're not, then I probably would go back and use this to find my slope. Because I'm not trying to figure out if this table is proportional or not. I'm just trying, because that's when you put y over x, correct? But if you subtract 420, you get 105. 315 to 210, you get 105. Here you get 105. So when you do 12 minus 9, you get 3. 9 minus 6 is 3. And 6 minus 3 is 3. So either way, I would have come up with y over x, which is 105 over 3, correct? Okay, and I could have simplified that. But, so I'm doing the change in y over the change in x, and we find out that it is 35 to 1 when it's simplified, which means it's 35 miles per hour. Okay? Because your X's are always on the left, your Y's are always on the right. So compare the speed of train C to the speeds of train A and train B. So all we need to do is say, what?
Train C is faster than train A, slower than train B.
Correct. Train C is faster than train A, but slower than train B. And that would be the correct answer. That is how to compare train C to A and then to B. Okay? Easy enough, simple enough, straightforward, pretty much, isn't it? Okay? All right. So, example 2. The equation y equals 11x represents the calories Jake burns when cross-country skiing, where x is the time in minutes and y is the number of calories. The graph shows the calories he burns while playing basketball. Which activity burns calories at a faster rate? Explain. Okay, so we've got cross-country. And we've got basketball. We're comparing those two things. All right, so first thing we need to do is we know what cross country is, don't we? If it's the equation y equals 11x, what are we burning here? X is the time in minutes. What? We're burning 11 calories per minute, right? Or for 1 minute, however you would like to say that, but per means 1, okay? So 11 calories per minute. Basketball, we've got to do a little work here, okay? First off, we're on a graph, so we're going to do what? Rise over run, correct? And I know it's kind of hard because this kind of didn't mimeograph correctly. So here's a line, here's a line, here's a line. So what are these lines going? How much are they worth? 500. So the first place we can really get a good idea is right here where it crosses. Okay? And I know the lines are really light, so I'm sorry about that. All right, but it's going up to how much? 1,500 and over to 2, right? So 15 over 2 gives us what? Simplified. 750, what are we, and I'm going to write this over 1, and then I'm going to rewrite it so that it's clear. 750 over 1, but what are we comparing here? Look at what your graph says. Is it 750 calories per minute? So it's 750 calories per hour. So how are we going to break that down? Because we can't compare hours and minutes, can we? So we're going, well, you could do that. So we're going to do, if 750 calories, how much is 1 hour? How much is it in minutes? I heard it, 60. So 60 minutes, then that gives us how much for 1 minute is the question? 12.5 calories per minute. So you have to be really careful that you're comparing the same intervals, okay, when you are comparing functions. So we've got 12.5 calories per minute. And it says, which activity burns the calories at a faster rate? Which one? faster rate is basketball because basketball has a higher rate of change, which is 12.5 per minute. Okay. Now, if you had given me basketball was higher and you still had basketball in hours, I probably would mark the thing wrong because you're not comparing the same thing. Okay? Because obviously 750 would be higher for every hour, but you really haven't done what you needed to do to get it down to. You've got to compare them to the same interval. All right, here we go. Example 3. A bowling alley offers different birthday party packages. Package A is represented by the function C is equal to 7p plus 5. Proportional or not proportional?
Not proportional.
Correct. Where C is the total cost and P is the number of people. What does that 5 represent? The y-intercept. So it's some kind of starting point that's not 0. So there must be a one-time charge, a room charge or something. Okay? So package B is represented in the table. Compare the functions. Okay, so we know what package A has, right? So let's compare this function. We've got to figure out what the rate of change is here. So we can do y2 minus y1, which would be y2 minus y1 over x2 minus x1. But I'll give you a hint. Anytime these are going by ones, you know that these will give you your rate of change. Because remember, your rate of change is by 1, correct? Does that make sense to y'all? Okay? So if these are going down by ones, that means the difference here is 1. Whatever the difference is here, and whatever the difference is here, and whatever the difference is here, is going to be your rate of change. It's going to be the same because those are going by ones. And that's when I do the change in y over the change in x, which is going to be a 1. And I get 32 minus 2550 gives me 650. And this one would give me 650. This one would give me 650. Well, what happens when I go down by 1 here? I get to my 0, which is my y-intercept, correct? So what is it here? 1250 minus 650 is how much? 1250 minus 650 is how much, people? 6. So my y-intercept is going to be 6, huh? So my rate of change is 650. So can I write an equation for this? You should be able to do this by now. All right, let's use C for cost. Okay, that's going to be our y is going to be represented by C. Our x is going to be represented by P for package, okay, just like they did before, so that we are comparing the same kind of information. So how much is it for the number of people? I'm sorry, P represents people. 6.5 is your rate of change per person. And then what else do you have? Plus 6. So you have a one-time charge of $6. So compare the functions. So what can we say about these two functions? What? They're not proportional, but compare them. What are we going to say? We can say this. Package A has a higher rate of change. Correct? Is that correct? Or cost per person, because that's what the rate of change is representing, correct? Cost per person. But a lower initial fee than package B. So while A is higher per person, the initial fee is less, correct? If 12 people attend the birthday party, which package will cost less and by how much? Okay, so package A is C equals 7P plus 5. So what am I going to do with those 12 people? Where am I going to substitute them? Where P is. C is equal to 7 times 12 plus 5. Cost is equal to 84 plus 5. And my cost is how much? $89. Okay? Cheap birthday party, let me tell you. Just wait till you have kids. Package B. C is equal to 650P plus 6. So now we're going to substitute in 12 at our P here. And we get 78 plus 6. And how much is 78 plus 6? $84. Okay. So it says compare and by how much. So we're going to answer this question. This is our proof. Okay. So you've written a proof now. Okay. Well, you haven't written a formal proof, but you've shown how the proof. Package B will cost less by $5. Simple enough. Okay. Last example. Example 4. Order the stocks from least to greatest rate of price increase. So least to greatest price increase. Well, let's see. For 0 socks, it cost us $21 in alpha. For week 1. Week 2, we went, what did we happen to hear? We're actually going down, aren't we? These are all ones. This is my what on top? X. This is my Y. So the change in Y over the change in X is, let's see here, 21 minus 1650 is how much? Negative 4.5, isn't it? I've gone down by 4.5. Do you agree? Here, I've gone down by 4.5. Here, I've gone down by 4.5. So I'm actually losing 4.5 every week. Subtract 4.5 over 1. So my price is going down by 4.5, 450 for each week. Okay? For alpha. Beta starting price is $54 and decreases weekly by $2.50. How would I show that rate of change? What? Right, minus $2.50 for 1 week, right? So let's just, I'm going to write equations. So this would be y equals negative 450. And what would be my y-intercept here? Plus 21, right? And here I'd have net y is equal to negative 250x, and I would be plus 54. Okay? Last one. Let's see here. Oh, we've got to fix this first, don't we? Because we can't decide anything in the format that it's in. Is it in a y equals format? No. So what are you going to solve for here when it says W is weeks and D is dollars? You're going to get your Y by itself, but which one is your Y? The D. Very good. X, and this is your Y. So we need to get our D by itself. So let's just come over here, and 7W minus 2D is equal to 54. So I'm going to subtract 7W from both sides. I've got negative 2D is equal to negative 7W plus 54. So now I've got to divide by negative 2 everything. And I end up with D, which is dollars. Did you really want to end up with dollars? Yes, you did. Just checking. All right, can I do anything with 7 halves at this point? No, 7 halves W. And here I would have 54 divided by negative 2 is negative 21. Everybody was thinking and didn't want to talk. Now, if this is money, do I want to leave it as a fraction? No. Oh, you're right, negative 27. Okay. So, do I want to leave this as a fraction? No. What do I want to put it in if it's dollars? Decimal. So, really, it's D is equal to 350 per week minus 27. If I put this in the same format as everything else, I would have had what? Y is equal to 350 x minus 27. Okay, what have I got here? Greatest rate of price increase, least to greatest rate of price increase. Here's what are your 3 price increases? What do you have?
Negative 4.5, negative 2.5, and then 3.5.
So I would list it as what? Alpha, beta, delta is least to greatest price increase. Negative 4.50, negative 2.50, and this is positive 3.50, correct? Yes, no, maybe so? Oh, I'm sorry, we're not done. Almost. What are the patterns? Let's see what's happening here. What are we doing here? We're going what? This is going up by what?
4.
So up by 4. Okay. What's going over here? What's happening here? These are all ones, so I'm pretty comfortable. What's happening on this side? They're going what?
Down.
They're going down by 2, right? Okay. What about this one? These are all ones, so I'm pretty comfortable over here. Looks like a parabola to me. What about to you? Do you see that? Can you see that? -1 would give you 0. 1 would give you 0. Looks like a parabola to me. This gives you, ooh, yeah. So, is there a constant rate of change? No constant rate of change. So what I might say is A and B have constant rate of change and are linear, because constant rate of change means they are linear, correct? C does not and is not linear, correct? Because it doesn't have a constant rate of change, therefore it cannot be linear. Plot each of the previous tables on the graphs below and write an equation for the linear functions. There we go. Okay, so let's see here. I can do -3 and 11. No, I can do -1, -3. I can do that for sure. I can do 0 and 1. I can do 2 and 9. 2 and 9 is a little hard, but I can do 1 and 5. And I've got 0 and 1. I'm sorry, I put that in the wrong spot. And I've got -1, -3, and I could draw a nice straight line here, especially if I had a ruler. There it is. And it says write an equation. Well, I know it's going up by 4, right? So, because if I did y2 minus y1 over x2 minus x1, for those of you who still need that, I've got 5 subtract 1 over 1 subtract 0, and I've got 4 over 1, which gives me a slope of 4. So I can do y is equal to 4x, and where's my y-intercept? At 1, positive 1, plus 1. So 4x plus 1. This one's going down by 2, and if you needed to know how to get your slope, I could do -6 subtract -4 over 1 subtract 0, and I would get, this would turn to a positive. I would get -2 over 1. There's my slope, and my y-intercept is at -4. So I know I can write this as y is equal to -2x minus 4. I know my y-intercept is going to be at -4. I can do -1 and -2, and I can do 0 and -2, and I can do 3 and, oh, you can't see? I'm so sorry. I can do 3 and 2, and that's probably enough to draw me a line. Am I going too fast for that? And on the last one, what have I got here? Write an equation. It only said for the linear function, so since the last one wasn't linear, you wouldn't have to do it. But I'm going to just show you what it would look like. It would be -1 in here, and this would be your little challenge. 3, -2 and 3, and 2 and 3, and here is your parabola. And remember that a parabola is always going to have an x squared. So y is equal to x squared, and where is your y-intercept? -1. Okay? And that's all I have for today. If you use your notes, oh, there's some challenges.